Hey guys, welcome back to IC Chris, where it's never too late to have an IC moment. I just want to say thank you so much for all the support. You guys have outdone yourselves. We're now sitting on 300 subscribers, so you've actually blown past the mark that I've set for today's goal, which was 250 subscribers. We'll be doing a live Q&A session on the 11th of May 2022, so that's this coming Wednesday. So tune in around 4 o'clock. I'll be going live. I will be doing some questions, and then you guys will have the opportunity to ask other questions thereafter. In today's video, we're going to be looking at question 6, which is more functions for paper 1 maths. So let's get into it. Okay, let's have a look at question 6. So question 6 is another function question. So over there we're looking at an exponential function. So they say given g of x equals to 3 to the power of x, write down the equation of the inverse of g in terms of y. Okay, so given over here, g of x equals 3 to the x, they want the inverse. Now remember, whenever we find the inverse function, we always set y equal to x. So we swap x and y around, and then we write everything in terms of y again. So we're going to have x equals to 3 to the y. Okay, but now y is in the exponent, so the only way we can get it out of the exponent is by using your log rules. Okay, so for log rules, we're going to drop and swap. Okay, that's how I like to remember it. You drop them and you swap them, so it becomes y equals to log base 3 x. Okay, and then that becomes the inverse of g. So g negative 1x equals to log 3x. Okay, now looking at 6.1.2, it says the points P, which is 6 and 11, lies on h of x, which is 3 to the power of x minus 4 plus 2. The graph of h is translated from g. Okay, so write down the coordinates of the points if they fell on g. Okay, so note that h is formed from g, so we've translated h from g, so this arrow should actually be that way. Okay, and now we want to find what would these points be if they fell on g. Okay, so let's quickly just note what's happened here. So originally we had g of x equals to 3 to the x. Okay, so let's have a look. From g of x to get h of x, we've shifted our graph to the right 4 units, and then we've shifted it up 4 units. Okay, so g of x looks something like this. Okay, so it will intercept at 1, because if that's 0, this becomes 1. So g of x looks something like this. That's y, that's x, and that's 1. Okay, but now h of x, what have we done? We've shifted it 4 units to the right. Remember, x minus 4 means we're going right. If it was a positive, we'd be going left. Okay, so we've shifted it 4 units to the right. So this point goes 1, 2, 3, 4. Okay, so it would be sitting over there, and then 2 units up, which means 1, so let's say 1, 2, so now it'd be at 3, so it'd be somewhere over there. Okay, so now the new intercept would be, let's see, if that's 0, that becomes 1 over 3 to the 4 plus 2. Okay, that becomes very small, so it's going to be in the region of 2. Okay, so just over 2 is going to be my my y intercept, and this is what h is going to look like. Okay, so let's see, how do we get back to g of x? Well, to get back to g of x, we've got to move 4 units left and 2 units down. So if I have the points 6 and 11, okay, which would be, 11 would be somewhere over here, so 6 and 11 would be quite high up over there, I'd have to move my x values 4 units left and my y values 2 units down. Okay, so just going up here, 6.1.2 continues. Okay, so my x needs to move 4 units left. Okay, and y needs to move down 2 units. Okay, so therefore it will be 6 minus 4 equals 2 for x. Okay, and then for y we'll have 11 minus 2, which equals 9. Okay, so the new coordinate p with respect to g would then be sitting at 2 and 9. Okay, now let's have a look at 6.2. Okay, so 6.2 says sketched is the graph f of x equals to 2 to the power of x plus p plus q. Then they give us that t lies on the graph, and then they also say that the asymptote f of f is y equals negative 16. Okay, so what they want us to do is they want us to determine p and q. Okay, so we have the following: f of x equals to 2x plus p plus q. Okay, then they tell us that we have an asymptote at y equals to negative 16. So the first thing that should be running through your head, they've given us the asymptote. Okay, so therefore we should be thinking of our q value already. Okay, because why? Your q value gives you your asymptote for your exponential functions. Okay, so q is going to equal to negative 16. Okay, that one was quite easy. And now we just need to find p. Okay, then they've given us the coordinate t, okay, which is 3 and 16. Okay, so all we have to do is plug this into the equation, knowing that q equals negative 16, and we can find where p is. Okay, so it's going to be 16 equals to 2 to the power of 3 plus p minus 16. Okay, which means I can take the minus 16 across. That becomes 32 equals to 2 to the 3 plus p. Okay, then what's going to be left? Let's see. 32 I can break down into a base of 2. Let's see, it's 2 to the power of 5. Yes. So 2 to the power of 3 plus p. Therefore, because the bases are the same, I can drop them. So 5 equals 3 plus p. So therefore, we have that p equals 2. Okay, you could have also used your log rules in order to sort this out, but then you would have to log on this side as well. But you can see that it's easier to find that these two have or 32 can be broken up into 2 to the power of 5. They have a common base of 2, and therefore we can drop them and solve for p. Okay, and that's how we go about doing this question. Okay, if you found today's video helpful, then please consider subscribing to the channel. Please hit a thumbs up as well, it helps me out a lot. If you have any questions or queries regarding this question, then please leave them in the comment section down below, and I'll get back to them as soon as I can. Once again, thank you very much for all the support on the channel. If you're not subscribed yet, please consider subscribing to the channel so that you guys can get notified when new videos come out. And remember, it's never too late to have an OSC moment.